Thanks everyone for coming. My name is Anthony Howell. Online I go by the Posh Wolf, so Howell, Wolf, that's the connection, Posh, PowerShell. But I had a really good, cool thought last night. I was like, what does the Posh Wolf look like? So I kind of went a little overboard with some AI generated images. We'll have some fun with that. But these are our sponsors this week. You know, you've heard this every session, I hope. Thank them. They are what makes this possible. And all of my sessions, including this one, is in this repository. You don't need to worry about taking pictures of the code. It's just the Posh Wolf /sessions. This deck will be on there. It's not there currently. I decided to edit it in OneDrive instead of Git, which is a good idea with non-text files. So just brief introduction. So I'm going to stop craning my neck. I'm Anthony Howell. I'm from Eugene, Oregon, so it's probably raining, but it isn't. It's just cloudy today. I got 4 kids, 2 dogs, and a wife, so that means that this week my wife's going crazy. So I'm going to thank her when I get home. And I've had a strange career. I had someone call it a choose your own adventure career. You guys remember those books? Yeah. I've done help desk, call center, field work, desktop support, sysadmin, DevOps, PowerShell, SRE. Was even a sales engineer for a startup that failed, cloud architect, and now I'm a director of DevOps at Evolent. They're paying for me to be here, so there's their logo. Thank you to Evolent for paying for me to be here. They'll probably watch this recording even. So yeah, I was really excited about that. So Posh Wolf, right? I need someone to do me a quick favor, take a picture of me up here and send it to me, Slack, email, Twitter, whatever. That just shows my wife that people actually think that PowerShell is cool, right? Because you try to explain it to your significant other who isn't in tech, and they're like, well, PowerShell, I've never heard of it. It must not be that cool, right? So, yeah, thank you all. I saw some people taking pictures. I'm on Slack, Anthony Howell, or Twitter. I'm not on Twitter very often, but, you will notice I don't list a blog on here. I do have a blog, theposhwolf.com. The last time I posted on it was a couple years ago. I'll revive it at some point, but 4 kids is a lot. I'll just leave it at that. What we're going to cover today, yeah, these are great. I love them. Quick refresher, what are Hashtables? What are PSCustomObjects? We're going to give some in-depth look on 4 different areas. And then I'm hoping we'll have time, but I got a really good case study of using Hashtables instead of PSCustomObjects. I find that in my career and talking to a lot of people that use PSObjects for everything, I got a really good use case for a real-world use case for using Hashtables, and we'll talk about why as we go through this demo. So this can all be done in PowerShell 5.1 and newer. I will be doing it PowerShell 7.4.1, so the latest version. I'll mention when there are known differences, and when I say known, I mean known to me. If you guys know some, shout them out. In VS Code and on Windows 10, so my laptop does not support Windows 11. Quick overview. So PSCustomObject itself, if we look at the help, so this is kind of squished, sorry about that. But you just help about PSCustomObject. This is a brief summary of that. PSCustomObject itself is a type accelerator introduced in PowerShell v3. We'll make fun of how PowerShell v2 used to do this. And a type accelerator is just, you notice on the right-hand side, we got PSCustomObject inside of the square brackets, and it's casting a hash table. If you don't know what that means, we'll go through some examples. And a type accelerator itself, the short version, it's an alias for a .NET type. And you can look at the help about type accelerators. And if you're not familiar with the syntax on the right, we'll look at it. Hashtables. They are what in programming languages are called dictionaries or associative arrays. If that doesn't mean anything to you, it didn't mean anything to me the first time I read it. I had to use them. The idea of a dictionary is you look up a word, you get the definition, right? You look up the key in a hash table, you get the value. That's where a dictionary comes from. I don't know where associative array comes from, so it's just another word that the docs use. But it's just a collection of key value pairs. So on the right-hand side, you see event equals DevOps Summit 2024, etc. But the interesting thing about hash tables is the keys and values can be any .NET type. So they don't have to be strings, they can be anything. And we'll look at a really crazy, pointless example that demonstrates this. But the thing to note, and as a kind of part of the summary of this presentation, is Hashtables are, and this is quoting the documentation, very efficient for finding and retrieving data. Okay, that is the one of the points of Hashtables. So demo time. Yeah, if I had too much fun, you guys just say so, okay? Yeah, so AI assumes that all the other individuals, if you will, in the image are also animals of some kind. So, except for the guy in the back, I guess. I mean, I don't know what happened with that. All right, so we got a lot of ground. I'm gonna go fast. If you guys got questions, just shout them out, raise your hand. Here we go. And all this code, it's in GitHub. So if it's something you guys wanna look at, great. So creating hash tables. We are starting with hash tables because PSCustomObject kind of build on hash tables. So there's a lot of ways to do it. You can use new object. So we can do that here. Oh, here, actually, I meant to do this before starting. Just cleaning up the prompt. All right, cool. So new object, type name, hash table, right? We can create a hash table with curly braces. Some people call them, is it mustache braces? Is that the one people like to use? I prefer curly braces, so I'm gonna use that. That creates a new hash table. It's empty. A lot of ways to add to it. Hash tables have the add method. So inside of the add method, you have key value. So in this case, we're using strings. So event is PowerShell Summit, date, and then the location. So pretty straightforward. And you can see the output there. This should kind of allude to what it's going to be in the future. Hash tables don't really output all that well. And we'll look at some examples of that and how to solve that. Easiest way to create a hash table is with the @ symbol, curly braces, and then your list of key values, right? Not meant that looks like what you do with PSCustomObjects. It's because it's very similar. And you can do this inline. I've worked with people that love their one-liners. Even using semicolons, you can do that with hash tables. Cool, it works. It's nothing different. One of the gotchas with hash tables is you can't sort the keys. I don't know why you would want to do that, but I just wanted to call that out. It's just one of the weird things with it. Unless you use the getEnumerator, and we'll get into what getEnumerator does when we talk about iterating in hash tables. And you will notice, and I meant to point this out earlier, I did not, date, location, event was not the order I inserted the keys into the hash table, right? I did event, date, location. Hash tables are unordered. So if you don't care about that, doesn't matter. But you can use the ordered type accelerator to make it a ordered hash table, which if we run this, you can see the keys or the order is maintained, but the type is different. And so it's actually a ordered dictionary instead of a hash table. So before, and I actually didn't have this as an example, we actually get the type is actually a hash table specifically, okay? And we can get really fancy with hash tables. So you can replace JSON with hash tables if you wanted to. I'm not recommending that, just throwing that out there, okay? So we can create a nested hash table. And I have actually seen somebody who was really into PowerShell, did all of their configurations in .ps1 files. It was just one big hash table. And that's really what a manifest is, right? Yeah, so maybe it's not so bad, I guess. And you can, there's no limit with hash tables. You can make them as large as you want. I just have a couple of contrived examples here that show several dates here. So you can see the keys here is the date itself. And this is going to be really important in one of my upcoming examples, so we'll keep moving here. And you will see that in the output there, it only shows so much of the nested values. And for anything too far deep, it does a toString method. So that's where when you do an object that doesn't have a toString method, it returns the prop or the type name. So that's where you get systems.collections.hashtables down below. And you can include arrays. So nothing really special here, except that we have an array of events inside of this hash table. So if we look at that, we get the array hash table, and that output looks especially bad, right? We don't know what's going on there. And there's a reason I'm mentioning that we'll get to. But we can look at the property of the hash table using dot notation here. And we'll look at a couple of the ways that we can access that. And arrays of hash tables. And this example here is really to drive home. I mean, we can scroll through this, like where does each object start and end? Or hash table start and end. And when you get to hash tables with lots of keys, that's not useful output, right? But we do see some nice, like the output here, the year, we can actually see what the year is. Older versions of PowerShell didn't have that nice display of some of the nested properties. And we can actually sort using an expression. So sort object, you can pass a hash table with an expression in it. So this is actually going to sort by the date year. So each has a key of a date has a key of a year. We can sort by that value specifically. As you can see, we got now the reverse. So the newest or the oldest is on the bottom. The most in the future is on the top. And we can pull from JSON. This is one of my favorite. I know this is really small. One of my favorite things about PowerShell 7, I think it was actually in PowerShell 6, is the as hash table with convert from JSON. And I'll have an example about why this is really cool, besides the fact that you get a hash table. Basically, it comes down to hash tables are really cool, and that's what I'm trying to convince you guys of here. So this is mock data that we're going to use in a case study. This is not a real person, not a real email address. Don't worry. And I mentioned we can do any type as a key. So here, this is a valid hash table, right? We've got booleans, we've got integers, we've got strings, we've got a date time, we've got a, whoop, sorry. I was always wondering why people's mouses were migrating down. It's because this thing is tilted. Sorry about that. And this is a valid hash table. And this is going to look especially weird. Oh, we did get an error. Oh, I'm not running as admin. That's not a problem. Cool. So you can see that we've got processes and services, and I didn't have the foresight to come up with a legitimate example. So there's just, you guys can use anything you want for keys and values. It's really flexible, unlike PS custom objects. So the same kind of deal with PS custom objects. If you haven't been using PowerShell since V2, you will not recognize this, as that's a good thing. But previously, to create a PS object, new object, type name PS object, and then for every member you wanted to add, you have to run add member explicitly. I looked at some of my old scripts, and it's painful. But it works, and it still works in PowerShell 7. So we can create an object with 3 different properties, and each property takes its own command to do so. And you can still use new object today using the property and passing a hash table to create a PS object. And again, that creates just the same type of object. Very simple. Thanks to PowerShell v3, we now have the PS custom object type accelerator. So that this is literally taking a hash table and makes it into PS custom object. That was one of my favorite features in PS v3. And of course, inline, it's just a hash table. If you are a semicolon junkie, there you go. That works too. I got a couple of examples here just to kind of compare with hash tables. So we're creating an array of PS custom objects. And you notice here the output, it's much easier to understand where one PS custom object stops, the next one starts, because it's formatted as a table, which is nice. We can sort them. I mean, really what I'm getting at here is PS custom, or PS objects in general, were built for the pipeline. Hash tables, not so much, okay? So we can pipe it to sorted object, we get exactly what we'd expect. We can do the same thing for select object, where object, all those good things. And we can do nested properties. So we can do, like the hash table, we can get really funky and build this weird, object. And that's legit. I mean, there's nothing crazy there. We get this nice output. We didn't used to see this nice nested output. So you see in the date and location properties, we can see some sub properties. It's really nice. And then from JSON, it's the same thing. We don't use the as hash table. The interesting thing is, considering hash tables of PS custom objects, if we were to do, want to choose one, we can look at the performance of it, which is what Rob was doing this morning. So if we load them as hash tables, and you can see it's as hash tables there, it takes about 1,800 milliseconds. And if we do it as PS objects, it's going to take a little bit longer. So it's not significant, but it's a little bit. But we'll look at some specific performance examples. Cool. Any questions so far? Just kind of creating in the basic stuff. Okay. So updating. So let's look at updating hash tables. So hash tables have a really cool thing where we can use the square bracket notation or dot notation, and they both operate the same way. Uh-oh. Phone's on silent, please. No, I'm just kidding. Don't worry about it.
2024 isn't real sin calling somebody at all.
Yeah. Yeah. The question was, 2024 is a real sin calling somebody at all. Sorry, I always forget to do that, so I'm taking advantage of this opportunity to remember to do that. So using the square bracket notation with the key, and in this case it's a string, so it's enclosed in single quotes, we can access and update the property. So before it was, well, it should have been Bellevue, I don't remember. We updated it to Redmond, so you can see it in the output. Same thing with dot notation. I mean, there's nothing special there. But the differentiator between hash tables and PSCustomObjects is that we can also add properties that way. So you notice in the output below, and I'm pointing at my screen like you guys look at my screen, in the output below, there's no military time, for example. So if we replace that, if we reference that property, it gets added in. PSCustomObjects don't do that, and I'll prove that to you in case you don't believe me. In dot notation, it's the same thing. I mean, that's the cool thing about hash tables is there's no additional work to add a property, but it can bite you if you are expecting to get an error like with PSCustomObject. And we do have the add method as well. We mentioned this in the previous script. It's all the same thing. And removing keys in the hash table, you just specify the key with remove. Pretty straightforward. And to list the keys, there is a keys property, and that has a list of all the keys that are in the hash table, and that'll come in handy when we talk about iterating in a hash table. And to find out if the hash table contains a specific key, we can look at the contains key method, which will return true, false, or the dash contains operator, since keys operates very similarly to an array, so it'll tell you if it's in there or not. And which is more efficient? So which would you use? And this is actually a weird one because the answer is ambiguous. And so using contains key, we get 65 milliseconds here. And if we use dash contains, we get 67. And actually have an example later on where it's the opposite. What's up, James?
Well, it's going to, the second one's going to lose the bigger the hash table gets.
Yes, and thank you. So James is saying the second one's going to lose as the hash table gets bigger. We have an example with a bigger hash table where the second one loses very badly. So thank you for that. Yeah.
So I understand the hash table is a lot faster because you're just indexing the keys, maybe bypass the data as needed. Is there a limit on key size?
Oh, the question is there a limit on hash table key size, like individual key size or number of?
The amount of data you can put in the key, the key name.
The key itself, is there, I don't know.
Hash table keys are all by identity, so you can give it a string that's as long as any string you can construct in the net, and so the limit is like 1 billion characters, so if you come up with a longer key,
The actual key was like an actual process. In that case, like, it's just an object. At that point, you were not going to even have that string key limit. You could have as much embedded within a sub-object as you want. Still,
again, any unique object you can pass as key, you can use, right?
All right, so the summary of the answers from the audience, thank you very much, is that the limit is based on the data type that you reference. So if you pass a string, whatever .NET's limit for a string is.
Yeah. I'm surprised by how much you can pay.
Yeah.
one
Yes.
more bit of nitpicky here, and this is just like, don't forget ordered and don't use contains key, use contains. Because when you use hash tables, they have slightly different signatures than other dictionaries. Ordered and hash table are both dictionaries. So if you use something that's on collections iDictionary, that's the method you want. Contains key only exists on hash tables. This will bite you. It exists on hash tables and PS-bound parameters, but not ordered.
So the additional information here is ordered dictionaries do not have contains key, they have contains, right?
Which hash tables also have.
Which hash tables also have.
So you might as well just write .contains, because it's going to always work.
All right, it's good to know. Though I will point out that this talk is on hash tables, not ordered dictionaries. But no, that is really good information. So for the recording, ordered dictionaries and hash tables both have .contains. Hash tables and PS-bound parameters, which I thought was a hash table, but it sounds like its own type, also or only have, so they both have both contains and contains key. So the summary here is use contains instead of contains key, so you can work with both. Thank you. All right. The last thing I wanted to show is we can access the properties from a variable. This should be pretty obvious with hash tables since we're using strings, so you can pass a string to a variable, and that's still a string, and use that to reference the properties. But just to show that location here is a string, we're going to go hash table dot, and then the variable. It might look kind of weird to you guys, but it works. And then same thing with using square bracket notation. And this works for PSCustomObjects too, which we'll look at next. All right. Oh, I'm sorry, guys. Grabbed the wrong one. Let's go to the next one. OK. So PSObjects, you can update the property by referencing it with dot notation, right? We know that. We've all used them. OK. Location is now different. But we can't add. So this is the thing I mentioned with hash tables. You can't add a property by referencing it like hash tables. So that is very different how it works. We can use add member. I mean, we've already looked at that. But add member also has a note properties member. This is something I learned at the PowerShell Summit one of the last couple times I was here. Note property members can take a hash table. You can add a bunch of properties at once if you want to use add member. That's cool. I didn't know that. And that works. So if you didn't know that, now you do too. But the cool thing about PSObjects is they have the PSObject property. It's a hidden property. You can't tab complete it. And so what that gives us is that gives us some additional metadata about that object. So it gives us the members, the properties, the methods, and then some additional .NET stuff, including the type names. And so we can use that to add properties as well. And this is something you're probably never going to use, and it's not a bad thing. What's that?
It's very fast.
Oh, and see, maybe so the response from James is it's very fast. I haven't benchmarked that. Maybe I should have done that. But that's also how you can remove a property as well with PSObject.properties.remove. In this case, you only need the name of the property, which address is what we're removing, and it's been removed. Cool. But that's how you can list out if you need an array of all the property names. You can use PSObject.properties.name, and that gives you just a very, very similar to hashtable.keys. It gives you an array of strings of the property names. In the case of hash tables, it may not always be strings, right? It could be anything. And if you want to expand that out, instead of doing dot notation, you can do pipe it to get member and select object. I mean, there's always more than one way to do things, right? And to test for properties, we can use the contains operator and see if it has a specific property, true, false. Yes.
You can also index in the properties. So you can say PSObject.properties dot or bracket location.
Give me that again.
You should be able to say .object.PSObject.properties bracket location to get back to location property. And I think you can do dotting with that as well. It might be one of those exceptional spots.
All right. I didn't know. Thank you. I'm gonna. So this is why I haven't committed these changes to main yet, because we're gonna add to them in the session. Cool. So another way to access these properties itself is to use this square bracket notation. Is there a name for square bracket notation? Index operator. Thank you. I always call it square bracket notation. So no longer. And then with PSCustomObjects, you can still access them by variable. So we'll assign location to the property variable, and we can do object dot property. You still get it? And we can, of course, also use the indexing notation. Just kidding. On PSObjects, indexing notation does not work. Oh, there we go. Cool. Any questions or maybe things I missed? Looking at you, James. No, I'm just kidding. OK. Hash tables. So we're going to talk outputting. So if you haven't gathered already, outputting in hash tables is not great. It's not meant for outputting, is what I'm going to get at. But there are some things we can do that you may not be familiar with. So for example, you can output multiple keys. I didn't know this. I learned this actually preparing for this presentation. But if you pass an array of keys, you get all of their values. Oh, I don't know why it's doing there we go. Cool. I don't have a good use for that because I just learned that like a week ago. But if we look at an array, we already did this. It's not great output. We can't even format it well. Format list. That doesn't make it a lot better. I mean, we can expand this out, and where does one hash table end when the next one begin? I mean, I don't need to drive this home too much. The same with format table. I mean, it's the same thing as before. One of the tricks you can use is convert it to JSON. That's what I do if I want to look at a hash table. And you can see that it's a lot easier to read, right? An array of hash tables, I mean, that gets to be a lot of data, especially if it's nested. You can control that with the depth parameter on convert to JSON. But select actually works. I put this in here because I didn't know that it worked. I thought it didn't work. And I'm sure it didn't work in a previous version of PowerShell, but I couldn't figure that out in time. But you can select a specific key out of an array of hash tables using select object. And of course, you can write in a file. So part of outputting objects is outputting them to disk, right? And we can do that I've done it with JSON and CSV. Works just fine. If you really want to output hash tables and see them, you should output them as PSCustomObjects. So we can do that here. So lines 24 to 26, I'm taking that array of hash tables we created earlier, and then they're each hash tables, so we can use the type accelerator. So that's exactly what we're doing. And we get PSObjects. That's really the best way to output hash tables. And of course, you can use the new object commandlet, and it gets the same thing. So the question is, if they both get the same output, which one's faster? So if we do type accelerator or use the type accelerator 10,000 times, takes almost right on the dot 1 second. If we do new object 10,000 times, it takes a little bit longer, 3 seconds. So type accelerator is faster, as you would expect from an accelerator, right? Okay, so with objects, we already know the output's pretty good. So I'm not going to spend too much time on this, but we output the object, we got a list. We can format to table, right? And you guys understand the difference between when it automatically formats to table versus list. It has to do with the number of properties. So the more properties it has, I think was it 3 or 4? Four, great, thank you. This is why I come to these things. So I can ask questions while I'm up here. You guys have to listen. Okay. And we can also transform properties with select object. Have you guys seen the name expression? I know there's some shorthand to do this, but for scripts, presentations, I'm not going to shorthand it. And so we can convert, for example, that date column to an actual date time with select object. We can assign that back to a variable and use that to do some conversions if we wanted. Outputting, it's the same. It's exactly the same as outputting hash tables, which is nice. But one of the biggest advantages of PSObjects is, and I'm sure you guys have seen this, with specifically talking about outputs, is here with get process. First of all, in PowerShell 7.4, you notice that several of the headers are italicized. It's when the actual name itself is different from the header value in the table. I forget what feature that was that got implemented, but that's cool. But what we're looking at here is, 5 or 6 values, and it's as a table by default. It's using PowerShell formatters. And we can do the same thing for get service. You can see that's not all of the properties on the service, that's only 3 of them. So we could write our own, and this is not we do a whole session on formatters. There's James has a module for making it really easy out. And I'm not even going to open this file. So object, it has, is that 6 properties? I've made a custom format that tells it to only output I forget which ones, a couple of them. So what I'm going to do is I'm going to import that format. I'm going to take, in this line 24, this is a little bit of magic here. I'm going to insert a type name onto that PSObject so that when it hits the formatter, it will find the format that matches that type and format it according to that type. And there's actually some really good use cases for that. So that object, and actually let's look at this right now. That object now has the my type. So PowerShell knows that if there's a format that formats that type, it will format it for us. And this is a crash course, guys. Sorry if this is mind-blowing. So now we only see the date and location. And there's some really cool use cases for that. See hand up? Yeah.
2 quickies here. One, you can also access and change these with another hidden property, $object.ps type names. Type a little bit less if you want.
You said PS type names? Ah, dang. Oh, it even auto-completed here in VS Code.
You can insert or add to that as well.
Oh, wow. See, yeah. Maybe we should swap places here.
I hope not.
No, I'm just kidding. All right, cool. There we go.
Number two, just in terms of getting good comment nomenclature around this thing, this is what I will commonly call decorating your objects.
Cool. Object decoration.
Here's my type name, go format me that way.
Okay, so let me back up a minute. Line 24, we are decorating our object with a new type name. All right, that was the additional comment for the recording. Cool. Yes, question.
I'm assuming you're inserting at index 0, that's a 0, and the formatting only applies to the index 0, is that correct? Like what if you had a different formatting for a different type?
I'm actually not sure what the answer is to that. Okay. So the question was, does it matter what, here on line 24, 0 is the index, does it matter where it goes? And the answer was that the formatter will find the first, in order, will find the first type that has a formatter and apply that. So if we want our type to be the one formatted, we put it at index 0. So cool. Thank you, Matthias. Yeah.
Just one other aha attached to that. If you want to change the way that a type is viewed, you can always rearrange those. So if I put it at index 0, that's going to be the first formatter. If I then took the second formatter and made it the first, well, it would be formatting like that. It will go down the list until it finds one. So by changing the order, we can change how it's formatted.
Cool. So the comment was we can reorder that if we want. And let's move on, since this is not a formatter talk, but that's some really good information, so that's why we're doing this. So, all right. So the other thing, you may want to convert a hash or a PS custom object to a hash table. This is how you can do it with a single, if you don't a PS custom object that only has one level of properties. We create a hash table, and then for each property, we iterate through the object.psobject.properties.name. We just assign it to that same property in the hash table. And there are reasons you might want to do this. I didn't have a good example to add in here. So, any other questions on that before we move on? Cool. All right, so let's talk about iterating. So iterating through hash tables and PS objects. So I mentioned get enumerator earlier. So this hash table has this method, and what it does is it will convert each key into a property that has the a key and value, or sorry, let me back up. It'll convert each item in the hash table into an object that has the key and value properties. So you can see in this example, I'm just iterating over them and outputting key, and so $_.key and $_.value. Sorry, I'm confusing myself while trying to explain this. So there we can see in the output. The other way we can iterate through a hash table, and this is iterating through each of the keys, is just to look at the keys property, and then we can index into the hash table. So on line 10, we can index into the hash table and get that value as well. And we can use dot notation instead of the index notation. Either way will work. So the question is, which is faster? Let's find out. So doing this 10,000 times with the get enumerator takes about a little over 500 milliseconds, and 10,000 times with the dot keys takes about 5. Well, I was expecting the opposite. So maybe it's close enough that it's back and forth. Sorry, I didn't prepare for that to be the opposite. Oh well. Okay. So you can use for each. Doesn't have to be for each object. There are some performance considerations when dealing with those. Rob had a great session on that this morning, I saw. For loops, while this looks like it would work, Copilot seems to think that'll work. You can't actually index into the keys property with this index notation, so that doesn't work. And don't try to modify hash tables while you're iterating through them. So you notice here, what'll happen is we're going to remove the first key. Well, we're going to try to remove all of them. But when we remove the first one, where'd the error? Oh, the error just was above. I was like, whoa, this is really screwing up. So we get an error here. The collection was modified. Enumeration operation may not execute. So it removes the first key, identifies that it's been modified, and exits the loop. And so you can look at a hash table. It no longer has the first key, which was event. So event was removed, and then it stopped. So it might introduce some really weird errors if you're trying to remove a bunch of keys and it only removes one of them. And iterating over an array of hash tables using dot notation in this case, I mean, it's the same as if you were iterating over any other array, right? They're just hash tables in an array. And there's nothing special there. Some of the properties, they get serialized as strings because there's sub-properties, so that's why we get the systems.collections.hashtables. And we can, if you want to look at it, I had someone ask me about very nested hash tables. So you can see here we have, and I made them ordered. So we have, A, A1, A2. So we have 3 orders of depth there. And we do with ABC, ABC. So it's a lot of ABCs. I couldn't come up with a legit use case, so I just did ABC. So we're gonna import this. And so there's a couple of ways we can do this. So in this case, we're going to output every single item, and I know how deep it is, so I know how now nested to do the for each. But you notice here at line 118, we get to a very nested hash table. We get key, subkey, subkey. And so if we want to do it this way, it becomes very important to name your keys in a way that it makes sense. And this does work. If we run this, we can output it. We can see the subkeys. We're not going to go through and validate all the output. Another approach to do this is to, on each level, is to assign that hash table to another variable. And we do that down at one depth, each step down. And so when we get down to the deepest version on line 132, we don't have that long index notation. It's 6 one, half dozen the others, my dad would say. It's the same thing. I did modify the output so it's nested key. It matches the variable names, but just a couple of ways to do that. Any questions on hash tables, iterating? Cool, a lot of info, kind of fast. All right. So PSObjects, I was fairly certain that you guys are all familiar with for eaches, so not a lot of examples here. It's just iterating through an array of objects. We get each of the properties. Not a really extensive examples here. For each object as well, and for actually works on an array of PSObjects. It doesn't work on the keys property, remember? And we can even use while. I mean, it's really how you want to do it. And you can see in the while, you just have to remember to increment the index there with X. But if we want to iterate through the properties on a PSCustomObject, we can look at the PSObject.properties array, and we can actually output the name and the value of that. So that's a fun little use case that might come in handy at some point. So you can see we're iterating through the properties on a single object, not an array. And so we're looking at the name, value. Cool. Any questions on that? All right, we got 6 minutes for my case study, which is perfect. So far, the moral is hash tables are fast. PSCustomObjects look pretty, right? So I had a project where I worked for a company that had multiple Active Directory forests, had a single Azure Active Directory tenant, and an SSO provider, one login. None of them were synced, which might explain why that company lost a few $1 billion this year. But I don't work for them anymore, so who cares? But I had a project where I had to match up all the users so that we could start syncing from the 2 different Active Directory forests into Azure AD, and then that syncs into the SSO provider. And so I had to match up users from 4 different systems, and the only unique identifier was the email address. So all the email addresses were all unique, regardless of the fact that they'd all been manually created in all 4 of these platforms. And so I went through a couple of iterations because I had to run it several times because we didn't have everybody at first, and it was a mess. I don't want to go too much detail here, but I have some mock data where I have, and we'll look at this here. I have 10,000 users, and so we users 1, and each user has an ID. They have first name, last name, and an email address. We're only going to focus on the ID and email address. I just wanted enough mock data to kind of feel semi-realistic. Okay. And we've got, so users 1, I'm just going to take the first 5,000 users. Users 2, I'm going to take all of them, but I'm going to reverse the ID so that we can see that the IDs are actually matching. We're not just matching on ID. We are actually matching on the email address. So our goal is to take all the users in users 1, which is 5,000 of them, match them up to the users in users 2, which there's 10,000 of, and do that as fast as possible, okay? Cool. So, oh, you know what, I should have taken this section out, so we're gonna pretend like you guys didn't see that. Okay, so, oh, and it auto-completes back. So, the first example here, so we're iterating through all 5,000 of users 1, so for each user 1 and users 1, and then we're going to use where object to filter the users 2 array, so where the email address is equal to the user 1 email. This little trick on the end, select object first 1, this tells it that when it finds the first match to just stop. This will actually save a lot of time. So that means it must be fast, right? Well, you guys already saw the little notes I had there. This actually takes, I think it was 2 or 3 minutes, right? Okay, it's not very fast. Where object, generally speaking, is not fast. So I'm just going to stop that, and my computer did not freeze up. So we're doing good.
You're using a PowerShell array.
Yeah, there we go. I was doing it the right way. Okay, so what if we do a for each and then a for each, and then when we find a user that matches, we break out, so we grab the data, first of all. I think I skipped that in the first part. We're just grabbing an array of IDs, so we can get ID 1 to ID 2 to match those up. We just break. So for eaches are fast, we know that, right? So if we run this, and I think this one goes fast enough that we probably shouldn't let that finish. But this takes about 20 seconds instead of a couple minutes. That's pretty quick. Is that fast enough? No, thank you. So the next iteration of this, we can create a generic list, a PS object, since this is just a generic PS object. And so I'm going to take the users 2, which is 10,000 users. I'm going to put them in a list. And then what I'm going to do is I'm going to iterate over users 1 like before. But on users 2, every time we find a match, we're going to remove that user from users 2. Since we know that that user is already matched, we don't have to deal with iterating over that object again, since we don't care about it anymore. Okay? That sounds like it should be pretty quick. So let's run this. And this actually finishes faster than I tested this morning. Okay? 87 milliseconds. Like, that's huge compared to 2 to 3 minutes. But is that fast enough? No, that's not fast enough. Okay? And the answer is because we're not using hash tables. Okay, so what about hash tables? So since in this case, we really care about the email address. That's what we care about, right? And so what I'm going to do is I'm going to convert users 2 into a hash table where every value is the email address. And this is a fake user, again, so don't worry. This is not somebody that works at my company. And we're going to take the email address and as the key, and the value is the hash table of the that user object, fake user object in this case. Okay? So we're going to create 2 hash tables, one of users 1, one of users 2. And you can see that I'm just taking the hash table, taking the email, assigning it to the user property. We got to go here. We got to go quick here. Cool. So we got 2 hash tables now. And so now, if we run through all the keys in users 1 hash table, and we see if the users 2 hash table contains that key, so that email address, and we're going to output that. And we're not doing any removes. We're not doing anything else. We're just using hash tables. And the difference here is it's a third faster. Or I don't know what's the math there. It's faster. It's 20 milliseconds faster, right? So instead of 80 something, it's now 60 milliseconds. So and I was like, well, what if we did remove it? Would that make it faster? The answer is, so you can see here that when we match it, we're actually remove it from the users 2 hash table. So like the generic list, it made it faster. So does it make the hash table faster? No, it actually doesn't, which is weird to me. But it doesn't. So that's good to know. So that's all we have time for. It's time right now. But really quick, using the dash contains, this is where it's actually slower than using the dot contains. And we can see here that it's like significantly slower. It's like, oh, gotta go get a coffee slower. 3 seconds instead of 60 milliseconds. So, I mean, it's not that bad, but you guys can understand. Cool. That's all I got. Any questions? Oh, hang on. Actually, you can hit me with questions. The moral is, because I have a moral. Oh, shoot. Where are we at? There we go. So the moral of the demo, really quick, use Hashtables for performance. Use PSCustomObjects for presentation. All right, any questions? I had too much fun with that. Cool. If you guys got questions, you can ask. Yeah.